Okay, this video is Manuka honey a good idea? Okay, it comes from the tradition of using honey for antimicrobial purposes, like rubbing it on the skin, especially in the context, let's say, of a burn patient, with the assumption that the burn patient was healthy before the burn. However, it comes to the attention when they talk about using honey for other medicinal purposes that Manuka honey is often considered perhaps the best of the honeys used in the context of putting it on a wound to prevent the wound from becoming infected. But if something is toxic to bacteria, that also almost always indicates it can be toxic to humans. So it turns out the unique thing about Manuka honey is that it has very high MethylGlyOxal. MethylGlyOxal is the starter chemical in diabetes for making advanced glycation end products. When you've got inhibition of intermitochondrial membrane electron transport and everything backs up, the mitochondria, then the cytoplasm glycolysis pathway. Okay, so what I'm basically saying is that doesn't sound good. I would not eat this stuff. There's other reasons why honey can have antimicrobial properties. It's got some hydrogen peroxide in it. It's also got some phenolic compounds. The phenol group is like a benzene ring with a hydroxyl group, and that is sort of a preservative, but that's also like part of the estrogen molecule. So I would wonder, could there be an estrogenic relationship? I don't know that, but whenever I hear the word phenol, I think estrogen, estrogen receptor activation. Okay. Okay, now here's just a quick look at what happens in diabetes. As you get a backup of all the pathways backing up glycolysis, it mostly backs up at this enzyme level, glyceraldehyde 3-phosphate dehydrogenase. And then side products are produced from the substrate, glyceraldehyde 3-phosphate, and you make MgO, methylglyoxal. It's a dicarbonyl, double bond between the carbon and the oxygen. There's two of them, so di as in two, dicarbonyls, and then it goes all over the place. It glycates proteins inside the cell and the cytoplasm. It goes into the extracellular space and it glycates collagen and it damages collagen. It's one of the reasons why diabetes damages collagen, and diabetes is associated with increased DISH in the spine, diffuse idiopathic skeletal hyperostosis. I've given lectures on that before. Goes into the blood, it'll glycate albumin. You can glycate hemoglobin A1C and whatnot. So anyways, then it can activate the so-called RAGE receptors for advanced glycation end products, and cause a lot of oxidative stress. So anyways, it's bad. All right, so let me just show you a couple more pictures of it to make sense out of it. Here's collagen. And in general, an important thing to know is that glycine is every third amino acid. That's the most important thing to know about the amino acids in collagen. Collagen is a big deal because it's 1/3 of the proteins in our body. Most of the time, you'll have every third amino acid, hydroxyproline or proline. And then the other ones are variable. You can get all kinds of things, including arginine and lysine, which are positively charged, and methylglyoxal will bind to them. So think of them as binding, to the arginines and lysines, and those will damage the collagen. So you don't want that. And this is just showing that Manuka honey, especially when it sits on the shelf, it'll tend to accumulate more of this methylglyoxal, and it can get up high, like around 835 milligrams per kilogram. Let's see, and this can be associated with increased tissue fibrosis, especially in the context of trying to heal an infection. I'll show you a little bit more about this. So here's the positively charged side chains in amino acids. Here is arginine, and then here is lysine. The standard amino acid has a carboxylic acid and an amino group. That's why they call it amino acid. But then the side group, these are the positively charged ones, the arginine and the lysine, and those have a tendency to form these advanced glycation end products. Here is the reaction. So here's methylglyoxal, dicarbonyl, double bond. Carbonyl is double bond between a carbon and an oxygen. And then the carbon is attracted to the nitrogen. And then the hydrogen comes off here, combines with the oxygen, and you get water coming off. And then you have this bond right here. This red line stands for this bond formed by this. I circled in yellow the methylglyoxal, so you can see this is the methylglyoxal. Here's the original amino acid, its side chain, in the context of a protein. And that's how an advanced glycation end product is formed. It's relatively irreversible. That's why it's called end product. This is just showing that you'll have a significant amount of arginine and lysine as well in your in your collagen. And here's another one showing, yeah, you got glycogen is every third amino acid. It's by far the most common amino acid. Then there's a lot of proline and hydroxyproline, but there's still arginines and lysines in there. And so that's it. So the bottom line is I wouldn't eat Manuka honey because I wouldn't want to add all those extra advanced glycation end products to my diet. And also it kind of comes from an animal, but I know some people use it as a sweetener. I would just, if you really want to use it as a sweetener, use some other brand. I wouldn't use it. I don't like sweeteners. But if somebody wants to, I wouldn't use Manuka brand for that reason.